Hello you guys, how's it going? So today we're going to be adding fractions. You guys are really familiar with how to add like fractions, so fractions that have the same denominator. But today we're going to be adding fractions that are unlike, so they're not going to have the same denominator. Today the denominators will be different. So it'll be a little bit trickier, but it'll be fine. We'll just take it step by step. So usually when we've been seeing problems, we've seen that the denominator was the same. So all we had to do was add the numerators together. But now, since the denominators are different, we're going to have to do something to it so that we have the same denominator. Because if they're not the same, it's really hard to add them together. So if you have like halves and fourths, for instance, do you see how different those are? It's tougher to add them together when they have a different denominator. But if they have the same one, like this, it's a lot easier to add these up. Okay, so we're going to try to make the denominators the same. So we're going to start with this story problem. It says, to finish building a birdhouse, Jordan uses 2 boards. One is half a foot long and the other is a fourth of a foot long. What is the total length of the boards? Okay, so I'm going to show you guys this one in blocks today just because it's nice to visualize it first before we start doing the actual math. But the first board is half a foot long, so there we can see a half. The other one is a fourth of a foot long, so it's this size. So as you can see, adding a fourth and a half together, it's kind of tough to see because they're different amounts, different denominators. So if we take this half and we think, okay, how many fourths are in a half? We can see, oh, 2 fourths go in a half. So we'll get rid of this. And now we can easily see the answer. And the answer is 1, 2, 3, or 3 fourths. So it's 3 fourths of a foot. Okay? So if you add a half and a fourth together, you get 3 fourths of a foot. So that's our first one, and we just kind of visualize that one with blocks. Now I'm going to show you another one. And this time we're going to do the actual math here down below. So the problem is, in the morning, an octopus swam for 1/3 of an hour. In the afternoon, the octopus swam for 1/4 of an hour. For how much of an hour did the octopus swim altogether? The word altogether, if you're thinking about what operation to use, would be addition. So that's why we have an addition sign right there. So the reason why this line is really long, because if you want, you can actually just do the math right here. But I'm actually going to show you a method I think is pretty nice, and it's really good. It's a good way to like organize all your thoughts. So it's called the 4 square method. Okay, and there's 4 things you're going to do. The first thing you're going to do is you're going to write the problem down. The second thing you're going to do is you're going to find the LCD. Then you're going to rewrite it after you find the LCD. And then you're going to, whatever the answer is, you'll simplify it. So you're going to do all 4 things for the 4 square method, okay? So I'm going to use this paper, and I sent this copy of this paper to your teachers if they want to share it with you. So, all right, let's go ahead and do this problem. So our problem is 1/3 plus 1/4. So I'm just going to write that in this square. Okay, so now we want to find the LCD, so the lowest common denominator, okay, between this and this. Okay, so I'm just going to count by 3s. I could keep going, but I think I'll stop there. Okay, and already I can see the 12s are going to be our lowest common denominator. So we're going to change our denominator on this to 12ths. Okay, so now we're going to rewrite the problem, but this time, instead of it looking like this, it's going to be in 12ths. So we're going to take a third and a fourth, these problems from up above, and I wrote it this way. The reason why I read it this way is because you can do your work off to the side, and if it's written like this, it's really hard to fit everything in. So I would recommend writing it this way, okay? So it's going to be in 12ths because that was our lowest common denominator. Okay, so now I'm going to change each of these fractions into 12ths. Okay, so it's going to go up, so I'm going to multiply, and I'm going to multiply here. And the question is, what do I multiply 3 by to get 12? And you would times 3 by 4 to get 12. So you have to do the same thing to the top, and you get 4. Okay, and for the next one, we're going to think, okay, what are we going to do to this 4 to get 12ths? And we're going to multiply it, but what would we multiply 4 by? You'd multiply it by 3. 4 times 3 is 12. So you have to do the same thing to the top. And here is our new problem. So we've rewritten it, okay? So now we can just easily add. This is what we did before. So, because we have 12ths on the bottom and now it's the same. So 4 plus 3 is 7, and it's still over 12ths. So I'm going to write it over here and see if I can simplify it. So I'm going to think, okay, 7's a prime number, so the only thing that goes into that is 1 and 7. So does the 7 go into 12? It doesn't. So we are done. And the answer to this problem is, for how much of 1 hour did the octopus swim altogether? It would be 7/12. Okay, so that was the next one. We're going to do one more problem. And again, if you want to do all the work right here, that's fine. But I would recommend using a paper like this. What you can also do is you can just get your, your paper that you're working with, and you can make a bunch of signs like this, but you'll probably want to leave more space, and you can just do it on your paper like this instead of like getting a separate paper for every single problem. So you can also make your own. Okay, here is our next story problem. Muna's family ate 2/3 of a strawberry pie, and Brendan's family ate 3/4 of a different strawberry pie. Wow, that sounds good. How much did they eat altogether? So we have 2/3 and 3/4, and again we have the word all together, which means add. So that's what we're doing, we're adding. Again, our denominators are different, so we're going to have to make them the same. All right, so here we go to our 4-square method. First step, write the problem. So we're going to write 2/3 plus 3/4. Just like that. Or you can write it that other way at first, that's fine. Okay, now we are going to find the LCD, or the lowest common denominator, between 4 and 3. Okay, I'm going to see if I have any matches here. And I see that 12 is our number we have in common for both. So our newest denominator is going to be a 12. Actually, I think that was the same as the last problem we did. Okay, so we're going to rewrite the problem in 12ths. So let's write that down. And I write a long line so I have some space. Okay, so it's going to be in 12ths. So that's what I'm saying. You can set up a 4-square like this, or you can just like do all these steps off to the side. It's up to you, however you want to organize it. This is just like a little organizer you could use. So, okay, so it's going to be in 12ths. So I need to make each of these fractions 12ths. So they're going up. So I'm going to multiply. So I'm going to make thirds into 12ths. So to make an equivalent fraction, whatever I multiply here needs to equal 1. So I'm going to think, okay, what do I multiply 3 by to get 12? And it's 4, because 3 times 4 is 12. So what do I multiply this number by? The same thing, because these equal 1. And if you multiply this by 1, it's still the same thing. Okay, so we have a new fraction right here. Now I'm going to do the next one, and we're going to times this by 3 to get 12ths. So we have to times this by 3. And we have 8 twelfths plus 9 twelfths now. So now we can just go ahead and add the numerators. So if we add 8 and 9, we get 17 over 12. Okay? So the problem is this is an improper fraction. This number on top is higher than this number right here. So I'm going to try to change it into an improper fraction, or sorry, a mixed number. This was an improper fraction. So I'm going to decide, okay, how many times does this 12 go into 17? Or how many times does 12 go into 17? And it goes in just once, because 2 12s is higher than 17, so it's just 1. So if I take a 12 out of 17, what am I left with? 5, right? Okay, so I'm going to put a 5 on top and leave the 12 on the bottom. So there is our new fraction. 1 and 5 twelfths. So the question is this simplified? So we can check and see. The only numbers that go into 5 are 1 and 5. So does a 5 go into 12? It doesn't. So this one is done. So this is the 4-square method. I would recommend using it. And again, you don't have to use like a huge paper like this. You can just use like a piece of notebook paper and write these 4 squares. But leave some space, because you're going to need some space to work through stuff. Like this is kind of tight. But I would recommend using this. And don't forget to simplify at the end. Okay, good luck you guys. You got this.